Okay, so today I'm going to talk about the extension theorem for codimension 2 subvarieties. So maybe this is the theorem 2.5 in my lecture notes. So it's a complex manifold. As I said, since we have not defined yet complex manifold, just take it Cn 0, an open set. Analytic subvariety of X such that the component of its codimension is bigger than 1. Again, we have not completely defined all these things. So at the end of the day, you will take just y equal to Zn equal to Zn minus 1 equal to 0. So during the course, when you learn all these concepts, you can return back to this theorem and digest everything. Anyway, any holomorphic function in x minus y, it extends to the holomorphic function in x. And again, the proof is basically applying Cauchy's integral formula in a proper way. Let's if you have a function here, function let's say defined defined in x minus y, then we can easily define this this function. So you see that at the end of the day, what is this? In the coordinates Zn minus 1 and Zn, we are just using the function over the boundary of the disk. This is the Zn minus 1, Zn. So at the end of the day, this f is well defined because none of its Zn or Zn coordinates is 0. And so anyway, this is a well-defined function. And again, by the holomorph, f is holomorphic in let's say in Z1 until Zn minus 2, because f itself it is, and it is also holomorphic in Zn and Zn minus 1 by just by this integral formula. So what we have to show that this f tilde coincide with this f tilde coincides with the f in at least in some open sets. So this is that we want to show f coincide with f in a neighborhood u of 0 in Cn. So since if we take z in u, then one of the Zn minus 1 and Zn is not 0. For simplicity, let's assume that Zn is not 0. Since Zn is not 0, since Zn is not 0, so this f function as a function of Zn minus 1 is holomorphic in the whole disk of Zn minus 1, because we have already taken zeta, let's say, let me say, okay, no. Well, let's try to from the beginning. Okay, so if Zn not equal to 0, so we can apply Cauchy integral formula in Zn, because zeta n in minus 1 which appears in this integral formula is not 0. And this means that at the end of the day, this function with zeta n minus 1 fixed is defined in the whole disk of Zn. This means that we can apply the Cauchy integral formula and write f tilde in this format. And so once we write f in this format, let's go to the okay. Once we write f tilde in this format, we can once again apply Cauchy formula in this zeta n minus 1 variable, and the reason is that this Zn is not 0. So this means that this function in Zn minus 1 is defined again in the whole disk. So again, we apply Cauchy integral formula and get the fact that f tilde is equal to f. Okay, let's